Alright guys, so for this video we're going to be talking about graphing linear inequalities. So if you guys know how to graph lines or linear equations, this is sort of the same idea here, except that instead of an equation or a regular line, we're going to be graphing a linear inequality. Now if you remember inequalities from way back when, we had the less than and the greater than symbol, and we also have the less than or equal to and the greater than or equal to symbol. If we wanted to graph inequalities with one variable, if you remember the ones that don't have the little line under it, those were open circles. The ones that had the little line under it were closed circles. So the first one meant we're not including that number. Second part meant we're actually including that number in particular. And then we also said that if the little Pac-Man or alligator eats the single variable, we shade to the right, which is the positive section. It's sort of the same idea here, but we're going to be transferring that into linear equations or lines. So how do we do that? So basically, for linear inequalities, we have to remember these symbols here, same idea as in the beginning. The less than and the greater than symbol. If they don't have the line under it, we're going to be drawing the line with dashes. And the dashed line means we're not including the particular line. So none of the points that are on that line are part of the solution. If it has a little line under it, so that means we're including that line. So in this case, we have a solid line, and that means that every single one of those points that's on the line is also part of our solution region. So that's the difference between not including and including. So basically solid dash means we're including all those points. Dash line means we're not including all those points. Remember, for inequalities, we have multiple answers. There could be more than one answer. There's an infinite number of answers. The question is, where are the answers at? And this is how we know. So the shade in an inequality represents the solution region. When the little alligator or Pac-Man is eating the variable y, we shade upwards, so above the line. Wherever that line was graphed, we shade above it. So instead of having y equals mx plus b, because it is an inequality, we're going to have one of these four options. It's either going to be y is less than mx plus b, y is greater than mx plus b, y is less than or equal to mx plus b, or y is greater than or equal to mx plus b. So if you remember how to graph a line, we're basically graphing lines. The only difference is that we're going to be doing a little bit extra. We're going to be shading the solution region for the line, and we're going to be determining which points on the line are including or not included in the solution region. So let's do a few examples to show you guys what I mean. So we'll do example 1, 2, and 3, and then we'll jump into example number 4. So example number 1, if you remember how to graph a line in the form y equals mx plus b, we're always going to start with the one without the x. In this case, the one without the x is a positive 1. So this positive 1 is called the y-intercept. It's always going to start on the y-axis, always on the y-axis, never on the x-axis. So positive 1 would actually be right here. This will be your first point, okay, on the y-axis. Now the slope, the number that is in front of the x, that happens to be 2 for this problem. So for slope, we always like writing slope as a fraction because that determines our rise over run. So I'm going to just write this as 2 over 1. Which doesn't change the answer, right? 2 is the same thing as 2 over 1. So if I have my first point and I go up 2 to the right 1, I get my second point and I can draw the line. But be careful, before you draw your line, this is no longer an equation, it's an inequality. So we have to look, are we going to draw a solid line or a dashed line? Well, if you look at the rule, when we have the little line under it, it's going to be a solid line. So in this case, we're going to have solid line. So feel free to connect the dots with a solid line. And then lastly, we have to figure out, do we shade above the line or below the line? Well, if the little alligator or Pac-Man is eating the y, we shade upwards. So in this case, it is not eating the y. So we would not shade up, we would shade down. How do we know which way is down? Well, if you go to the y-intercept, below that point would be down. So we're actually going to be shading this region here. So with your pencil or color, whatever it is you guys have available to you, this is all of the solution region for this inequality here. So if they were to ask you, is this point a solution? You would say yes. Is this point a solution? You would say yes. Is the point on the line a solution? You would say yes, because we're including the line, remember. Any point that's outside of the line and not in the solution region or where we shade it, then it would be a no. So anything up in this area would be not part of the solutions. Okay, example number 2. Same idea. So we want to graph 3 over 4x minus 2. Y is greater than 3 over 4x minus 2. So we're starting on the y-axis, which is right here, at the negative 2. So down 2 squares, put a little point on there. Then the slope is 3 over 4. We actually have it as a fraction this time, which is good for us because we can just straight up graph. So if we go up 3 to the right 4, Starting here, we go 1, 2, 3 to the right, 1, 2, 3, 4. Remember, we always start at the y-intercept. So up 3 to the right 4. Connect the dots. Before you connect the dots, do we have a line under the inequality or no? In this case, the answer is no, meaning that we're not including the line. So before you start connecting stuff, make sure you check yourself before you wreck yourself. So this will be dashes, meaning that we're not including the solutions on the line. And then finally, is the alligator eating the y? Well, yes, it is. That means that we shade upwards. It's eating the y, we shade up. So go ahead and just, with your pencil, shade above this line. So all of the solution region for this inequality is above the line. I'm going to go ahead and shade that in. And there is your second graph. So if they were to ask you, is any point here part of the solution? The answer is yes. Is a point on the line part of the solution? The answer is no, because this time it's dashed. Is a point outside of the line part of the solution? The answer is no, because it's not where we shaded. Okay. Graph, -1 over 2x plus 3. So we're starting at the positive 3 this time. So up 3 squares on the y-axis. The slope is -1 over 2. So this time it's going to be a little bit different because we're going to be going down instead of up. So down 1 to the right 2, starting at the y-intercept. So if we do that, we go down 1 squared to the right 2. Solid or dashed? This time it's going to be solid. So feel free to connect the dots with a solid line. So I'm going to connect it. Okay, and then do we shade above or below the line? Well, the little alligator is not eating the y, so we shade below. So if you're wondering which way is below, again, go to the y-intercept. Below that would be below the line. So shade it in. And this is the solution region for all of our solutions that we can possibly have, including all of the points that are on the line. So we have many, many, many answers. The only other thing you might get, and you might freak out when you get it, is they want you to graph something that looks like this. Well, if you remember one of my last videos on standard form to slope intercept form, it's called. So from standard form to slope intercept form, we first got to move stuff around to get the y by itself. Once we get the y by itself, then we can graph it. So let's do that. So I'm going to go ahead and just put a little box around the y. I want to graph it, so I want to get the y by itself. So line down the inequality. The one that's furthest away from the y, I start with that one, which is the 5x. So I'm going to subtract 5x on both sides. Subtract 5x here, subtract 5x there. Negative 3y gets dropped down. We get less than or equal to 15 and negative 5x are not like terms, so be careful. They cannot be combined. So I'm just going to rewrite them as negative 5x plus 15. So since they don't get combined, we just rewrite them long ways. So almost done. All we have to do now is divide the inequality by whatever's in front of the y, so we can get the y by itself. This is a little important though. When we're dividing by -3, notice that the -3's cancel, but when we divide the other side by -3. Does anyone remember what happens when you divide by a negative number to the inequality? So this is the part that you have to remember. When you divide by a negative number in an inequality, the inequality is going to flip. It's going to be going the other way now. So instead of having this as the final answer, we're going to have y is greater than or equal to, because the inequality flips when we divide by a negative. That stuff on top, so negative 5x over negative 3, plus 15 over negative 3. Okay, finally, so we're almost done. We have to simplify this. We want to get rid of the negative, so this will end up being y is greater than or equal to 5 over 3x, and then plus, actually no, this will be a negative. 15 divided by negative 3 will be negative 5. So the final answer, and it's something we could actually graph, is y is greater than or equal to 5x minus 5. 5 over 3x minus 5. And we did example 1, excuse me. We did example number 1, 2, and 3 that looks just like that. So we just basically have to finish the job. So starting at the negative 5 on the y-axis, so if you go to the y-axis, down 5, 1, 2, 3, 4, 5, here we are. The slope is 5 over 3, that means it's positive, so we go up 5, 1, 2, 3, 4, 5, to the right 3, 1, 2, 3. We have our 2 points. If you connect the 2 points, you get a line, but be careful, we have to check solid or dashed. In this case, the little line under it means we're going to have a solid line. So connect those 2 points with a solid line. Oh, Close enough, pretend it's straight. And then finally, do we shade above or below the line? In this case, we shade above the line because it's eating the y. So we're going to be shading all of this section here. So all of the solutions are above that line, including all the numbers on the line. Okay, I hope this helped. See you guys on the next one.